These are the practice problems for lesson 6, strategic solving. And there are 3 problems for problem number 1. And you're supposed to explain or show your reasoning for each step as you solve these equations. So I'm going to list those reasons on the right side as I go through the solution. So A, the first thing I'm going to do is change all of the subtraction to addition. So I'm going to do that by adding the additive inverse. So subtract a positive 5b is the same as adding a negative 5b. Subtracting a positive 5 is the same as adding a negative 5. Doing that means that I can now use the commutative property to move things around and get things right next to each other. So it's easy for me to now collect terms that are the same, collect like terms. So there's 2b and a negative 5b. That is equal to negative 3b. Negative 13 plus a negative 5 is negative 18. The next thing I'm going to do is get rid of either the terms with the variable or just the numbers by adding the additive inverse. And because everything's addition, so now I can add the additive inverse. I don't have to think of any other operation. And so the first thing I'm going to do is get rid of this negative 3b. I could get rid of this 8b right here, but that would mean that the b's would be negative. I'd end up with a negative 11b over here. But if I get rid of the negative 3b, I'm going to end up with a positive 11b on this side. And I want the b's to be positive, just easier to work with if I make them positive. So add a positive 3b to both sides. Gets rid of this negative 3b, end up with 11. And on this side, it's 11b plus negative 18. And so now you get rid of the negative 18 by adding a positive 18. So remove negative 18 by adding the additive inverse. You end up with 29 equals 11b. And this is going to be pretty tough because you're going to get rid of this coefficient of 11 by multiplying by the multiplicative inverse, 1/11. Well, 1/11 of 11 things is one of those things. So it's 1b. So 1/11 times 11, this becomes 1. But you also have to look at 1/11 of 29. If you're going to look at 1/11 of 11b to see a single b, you have to look at 1/11 of 29. So this becomes 29/11. So b equals 29/11. Now this fraction, 29/11, is pretty tough to work with. You're going to replace b up here and show that it in fact is the solution to this equation. So here's 29/11, 29/11, and 29/11. Now, as you work through this, don't immediately multiply 2 times 29/11 or negative 5 times 29/11 or 8 times 29/11. Keep that fraction as 29/11 as long as you can. It is no different than when we solve this, keeping this as b. So instead of 2b, you have 2 29/11. Instead of a negative 5b, you have a negative 5 29/11. So you can treat that as 2 plus negative 5, 2 plus negative 5. I'm factoring out the 29/11. I'm taking that out, dividing by 29/11 basically, and I'm left with 2 plus negative 5, which means I'm going to have a negative 3 29/11. That's no different than back here than having a negative 3b right here. Negative 3b, negative 3 29/11. So plus 11. So I'm going to continue to work down this side. I'm going to get rid of this negative 29/11 by adding a positive, negative 3 times 29/11, or negative 3 29/11, by adding a positive 3 29/11. So this goes away. This becomes 0, and you're left with 11 on this side. On this side, negative 18 plus 8 29/11. Well, I added a positive 3 29/11 right here. So now I have 11 of these 29/11. I know it's hard to say and hard to think about, but it's no different than having 11b. You had a negative 3b plus a positive 3b equals 8 b plus a positive 3b, that is equal to 11b, or 11 29/11ths. So 11 is equal to negative 18 plus 11 times 29/11ths. So this becomes 29. 11 of these 29/11ths equals 29. This, I see, this just turns out to be 11. And it's the way they design the problem. So 11 times 29/11ths equals 29. And that's right here. I'm skipping around a little bit too much. So negative 18 plus 11 and 29/11ths. So get rid of this negative 18 by adding a positive 18. Oh, on this side it becomes 29. On this side you're left with 11 of those 29/11ths. Well, 11 of 29/11ths means you're going to have 29 whole things left. So 11 divided by 11 is 29. Or 11 times 1/11th is 29. So anyway, you get 29 equals 29. So a bit tough, but just remember to think of it as keeping this as 29/11ths as a single thing that you don't want to multiply by the number, because that's going to make it much harder to work with. And so remember, it's not any different than keeping this as a b throughout solving the equation. For problem 1b, I'm going to do the same thing. I'm going to write the reason that I'm doing each step over here on the right side. And the first thing I'm going to do, as always, is I'm going to change all the subtraction to addition. So this is adding a negative 5x and adding a negative 12x. So now I'm going to use both the commutative properties and the distributive properties to move all of the terms that are the same together so I can combine them. So the distributive property, I want to use that because I want to get the total number of things that I have in these three groups separated out so I can move them around. So if I have 5 things in 3 boxes, that means I have a total of 15 things. Likewise, if I have 6x things in 3 boxes, I have a total of 18x things, or 18 x's altogether. So now everything is addition. I can move things around. I can put the x's next to each other, the numbers next to each other, the x's here next to each other, and the 15. And so now I can collect all the like terms together. That means collect all the numbers together and collect all the x's together. So I have a total of a negative 3x plus 15 equals 15 plus 6x. And you can see that you're going to take the 15 away from each side. You're going to be left with a negative 3x equals 6x. So this is removing the 15 by adding the additive inverse. And you can see from this that x has to be 0. If I have a factor times x equal to a different factor times that same x, x has to equal 0. That's the only way that you can have that happen. It's like saying I have 3 times 2 equals 5 times 2 and somehow making those equal. They will not be equal because they are different pairs of factors. The only way that it can be equal is if one of those factors is 0. So x is 0. But to show it further, I'm going to add a positive 3x to get rid of this negative 3x. So this becomes 0 on this side, and that is equal to 9x. Get rid of the 9 as the coefficient by multiplying by 1/9. Once again, I want to look at 1/9 of 9 things. That means I'm going to look at one thing. I'm going to see the value of one thing as 1/9 of 0. 1/9 of 0 is 0. And so x equals 0. Now, to prove that 0 is the solution to the equation, I'm going to replace x with 0. And once you do that, you see that anything times 0 equals 0. So it makes the equation much easier to work with. So 2 times 0 is 0. Negative 5 times 0 is 0. 6 times 0 is 0. And negative 12 times 0 is 0. So now you're just left with 8 plus 7 is 15. And 3 times this 5 here is 15. Well, 15 equals 15. So it shows that the solution to this equation is 0. X equals 0. This is problem 1c. Again, the same idea. Wherever I have subtraction, I'm going to change that subtraction to addition by adding the additive inverse of positive 3 is a negative 3. By adding the additive inverse of a positive c is a negative c. And so now I'm going to use the distributive property. I want to know how many things I have in these two groups separately. I want to, in essence, take them out of the groups. So if I have 6 things in 2 groups, if I imagine taking 6 things out of 2 different boxes, I'm going to have a total of 12 things. And if I have a negative c in 2 groups, I'm going to have 2 negative c's or a negative 2c. So that's using the distributive property. 2 times 6 is 12, and 2 times a negative c is a negative 2c. And so things are, the like terms are right next to each other, so I don't have to use the commutative property at all. So 7 plus a negative 2 is 5c, 12, negative 3, and 2c. So I collected the like terms. And now I'm going to remove the I'm going to remove the positive 2c, from this side by adding a negative 2c. And so add a negative 2c here. So 5 plus a negative 2 is 3c. So that gets rid of this 2c. And now you're left with a positive 3c on this side because you're adding a negative 2c here. And remove this 12 from this side by adding a negative 12. A negative 3 plus negative 12, negative 15. This becomes 3c on this side. So 3c equals negative 15. So if 1/3 of 3c is c, then you have to calculate what 1/3 of negative 15 is. So 1/3 of this side, you have to also look at 1/3 of this side. So 1/3 of negative 15 is negative 5. So remove the coefficient of 3 by using the multiplicative inverse, which is 1/3. So c equals negative 5. And to test that in the equation to see if it is the proper solution, c is in fact equal to negative 5. So here's the negative 5 for c, this c right here, and here's the negative 5 for this c right here. So 2 times negative 5 is negative 10 plus negative 3. Remember, use the distributive property. Actually, you don't have to use the distributive property here. I could have just added these together. 6 plus 5 is 11. 2 times 11 is 22. That's 22 right here. But I did use the distributive property. So 2 times 6 is 12. And 2 times 5 is 10. And you get the same 22. Now, I'm being a little bit tricky right here. I'm going to add that to negative 35. So this is 22 plus a negative 35. And what I did is I separated out a negative 22. And so if you do that, you can see that a negative 22 plus a negative 13 is this negative 35 right here. Well, the reason I did that is 22 plus a negative 22, it's this additive inverse, the additive inverse of 22. This equals 0. And so you're left with negative 13. A little bit, I didn't do this in a very straightforward way. It's really just using a sense of the numbers, seeing that, I can pull out a negative 22 from here. This becomes 0, and I'm left with negative 13. So negative 13 equals negative 13. As I worked through problem 1, I noticed that I was using the same phrases in the same order for each problem. And those phrases were, the first thing I was always doing was adding the additive inverse. So I was changing everything to addition by adding the additive inverse either of a number or a term with a variable. Then I would use actually the distributive property next to get everything out of the parentheses. I wanted everything as single terms without any parentheses. So it's like finding out all the things separately that are within a group by using the distributive property. Then I would use the commutative property to move things around. So we get all the numbers in the same, right next to each other, and get all the terms with variables next to each other, then collect those like terms, and there should be an R here for terms, collect those like terms, and then I could remove the numbers from one side by using the additive inverse, and I could remove the variable from the other side by using its additive inverse, and then finally, to get rid of the coefficient, I would use the multiplicative inverse. So these were the same, I was using the same steps every time. And so I thought I'd just put together a short little video on that. And this page is also in the PDF that goes along with this video. In problem number 2, you are asked to solve each of these equations and also check your solution. In problem number 1, you actually weren't asked to check your solution, although I showed that check anyway. But you were asked to explain or reason why you took each step or how you solved each of these equations. In problem number 2, you're not asked to do that. You're not asked to explain anything or reason through anything, just to work through it and check your solution. Now in problem A, I just want you to take a look for a moment and see if you can't, just by looking at this, can you see that this becomes 4w? Because you're going to add a positive 3w to get rid of that negative 3w. Well, that's going to end up being a positive 3w over here. It's going to end up being a total of 4w's. And then on the other side, this is subtracting 4 or adding a negative 4. This is going to become adding a negative 3. Well, a negative 3 plus a negative 4 is negative 7. So 4w equals negative 7, and you're going to multiply by 1/4 to get rid of that 4. And so w is going to equal a negative 7/4. So you might be able to just see that by looking at it. You get faster and faster as you practice these problems and you start to see these things. So let's go through it step by step. I'm going to change the subtraction to addition. So this is adding in the additive inverse, so negative 4. And now I want to get rid of that negative 3w on this side. I want to work with positive w's. So I'm going to get rid of the negative 3w by adding its additive inverse. Add its additive inverse over here. And so the next step is I'm going to get rid of this 3. So now I have a negative 4, this negative 4 here, 4w plus 3. And now I have to get rid of that 3 by adding a negative 3. And I end up with negative 7 equals 4w. And now I want to get rid of the coefficient. So 1/4, if I have 4 things, I want to look at one of those things. That's 1/4 of those 4 things. At the same time, I have to look at 1/4 of negative 7. So 1/4 of negative 7 is negative 7/4. So these 4's cancel out because I'm looking at now one of those. And so I end up with w equals negative 7/4. Now to check this, you can take the negative 7/4 and replace it with w. And I'm going to zoom in on this. So negative 7/4, this is where the w was. And I have always just thought about this. Well, you just multiply this out. 3 times a negative 7/4, the opposite of that. This would be negative 21/4, but the opposite of that is a positive 21/4. Here is subtracting 4. You could add a negative 4. Over here, you have 7/4. I'm going to want to do some addition. So I'm going to change the 3 to 4ths. So multiply by 4 over 4. That becomes 12/4. And now it's 21 plus a negative 16, or 21 minus 16. That's 5/4. And over here, it's 12 plus negative 7 is also equal to 5/4. So you get 5/4 equals 5/4. Now, in looking at how the authors are showing some of these solutions, I had a revelation. I had never thought of this before. But instead of doing this multiplication, I'm going to treat this as a unit, essentially as a w. So I have a negative 3 of these things. And over here, I have a negative, or I have 1 of these things. So I'm going to show that on this page. So instead of multiplying, I'm going to look at this as a negative 3 of these negative 7/4. Down here, it's no different than looking at it as a negative 3w. We'll just keep it as negative 7/4. And now I have 1 of those same things. It's like having 1w. Now, if I want to get rid of this, I can add its additive inverse, which is a negative 1w, or a negative 1 negative 7/4. Hard to say, easier to write. Negative 1 negative 7/4. So add these two together, it becomes 0. This is negative 7/4. This is actually a positive 7/4. But I want you to see that it's one of them. So I'm going to keep that 1 there. So just like down here, it's the additive inverse. This becomes 0. This becomes 0. But on this side, I'm adding a negative 1, negative 7/4. So negative 1, negative 7/4. Now add these two together. What do you get? You get a negative 4 of these negative 7/4. Again, it's kind of hard to say, but you start looking at it this way. You don't have to do any multiplication with the fractions until the very end. Now, if I have a negative 4, so if I have 4 negative 7/4, that's a negative 7/4, and then the opposite of that, I'm sorry, it's a negative 7, and the opposite of that is a positive 7. Let me say that again. If I have 4 negative 7/4, then I have negative 7. These 4's cancel out. It's 4 times these 7/4. Gives you an answer of 7. Now, it might take some practice to actually see that and understand that, but an easier way and a way people memorize is that these 4's cancel out. Why they cancel out should take some practice in working that out. So this becomes a negative 7, but then the opposite of that, don't forget that negative sign there, is a positive 7. So now I have 7 plus a negative 4, or 7 minus 4 is 3. Down this side, this became 0, so you're left with 3. So it's 3 on this side as well. So 3 equals 3. So it is a solution to the equation. So W does equal a negative 7/4. This is a new way for me, a new way of thinking about it. Rather than just doing the multiplication right away, thinking about it as a number of units, whatever this is, combining them, adding the additive inverse to get rid of some of them. It's a new way of thinking about it for me. Okay, for problem 2b, can you see that if you just look at this closely, can you see that this is 9, 3 times 3 is 9, minus 9x. I'm not going to go through any of the steps. I'm going to just take some shortcuts and see if you can see the answer relatively quickly. So this becomes 9 minus 9x. This is equal to 2x, there's 2x right there, plus 6. 2 times 3 is 6, 2x plus 6, and then minus that 30. And so this becomes 9, so you're going to add 9x. 2x plus 9x is 11x, so 9 equals 11x plus negative 24. So 6 minus 30, or 6 plus a negative 30, is negative 24. And then 1/11 of that, so 33 divided by 11 is 3, and x equals 3. So take a look at that, see if you can see it relatively quickly, but then be able to explain each step, going through it step by step. So on this side, I'm going to change everything to adding the additive inverse. So add a negative 3x, add a negative 30. And I've been using parentheses around parentheses. That can be kind of confusing. So you can change it to brackets if you want, to make it a little bit more easy to see what's inside a group. And then if you have a smaller group inside a larger group, that's a way to show that. And so this becomes 3 of these 3 things inside the brackets. So 3 times 3 is 9. 3 of the negative 3x's is a negative 9x. So the multiplication is right here. 3 times 3, 3 times a negative 3x. This is 2 x's and 2 3's. 2 times 3 is 6, plus a negative 30. So I want to get rid of the negative 9x. I want to work with positive x's. So get rid of the negative 9x by adding a positive 9x. Add a positive 9x over here. You end up with 9 equals 11x plus negative 24. Same as over here. 9 equals 11x plus negative 24. So then you have to get rid of this negative 24 by adding a positive 24. Add a positive 24. 33 equals 11x. 33 equals 11x over here. Now I want, if I have 11 things, I want to know what one of those things equals. So I need to look at 1/11 of those 11 things. And I'm going to have to look at 1/11 of 33. So 1/11 of those 11 things is just one of them, so that's x. And 1/11 of 33 is 33 divided by 11 is 3. 3 times 11 is 33. So 1/11 of 33 is 3. So x equals 3. Now to check that, take the 3, replace x with 3. So here's the 3 here, and here's the 3 here. Zoom in on that a little bit, and you just go through the calculations. So this is 3 minus 3 groups of 3. You can't subtract 3 minus 3 first and then say it's 0 times 3, because this 3 times 3 goes together. Remember, that was 3x. That was 3 of these things. So you can't all of a sudden say, I'm going to subtract this 3 from that 3. This is the coefficient of x. This tells you how many x's you have. So you have to work with that first. So now I have 3 of these x's, which are equal to 3. That means I have 9 of them. So now I can subtract the 9 or add -9. 3 plus -9 is -6. And I have 3 of those. 3 times what's inside these parentheses is -18. On this side, it's 3 plus 3 is 6. 2 times 6 is 12. So notice you can't say 6 minus 30. It's 2 6's. So you have to multiply the 2 times 6 first. 2 times 6 is 12 plus -30 equals -18. So again, -18 equals -18. And right here I'm just showing a way that you can do this in your head. This might be easy for some of you, and maybe for some of you it's not so easy. But if you look at 12 as 10 plus 2, and look at -30 as a -10 plus -20. I have 10 here. I know I can get a -10 out of here. So -10 plus -20, well, 10 plus -10 is 0. You're left with 2 plus -20, a little bit easier to see that that's -18. If you look up here, -30 plus 12, -30, and I'm going to add a +10 to that. That gets me to -20. And then add another +2, that gets me to -18. Couple ways to think about that. This is problem 2C, and I don't really see any easy ways to solve this. I'm just going to have to work through this. So it's going to be 1/3 of whatever's inside these parentheses, and then subtract 6 from that, or add a -6, and 2/3 of whatever's inside these parentheses. So the first thing I'm going to do is change everything to addition by adding the additive inverse. So add a -6 and add a -z. And I'm also going to change these parentheses to brackets just to make it easier to see what I'm doing here. So now I have 1/3 of z. Oh, okay. Forgot that I did this. So I multiplied through by 3 first to get rid of the fraction. So that's a good way to do that. So 3 times 1/3 is going to be 1. This is going to be 3 times -6. So you have to remember to multiply each term by 3. 3 times -6. 3 times 2/3 is going to be that 2. And so that's multiplying all of this by 3. So you're left with 1 of these z plus 4's plus -18 equals 2 of these 5 plus -z's. Yeah, that's a better way to do it. That's a good way to do it rather than to work with the fractions. So now down here it's z plus 4 plus -18 equals 10. So use the distributive property. 2 times this 5 here is a +10, and 2 times -z is a -2z. Now I want to get rid of the -2z. Let's see what I did first here. Oh, I got rid of the -18 first by adding a +18. Oh, I just combined them. Sorry about that. So this is z plus 4 plus -18 is a -14. Yeah, you have to add the 4 plus -18 first to simplifying this equation. All right, so by combining like terms. All right, so now I'm going to add a +2z first to make the z's positive on this side. So +2z, this makes this 0. z plus 2z is 3z, and plus negative 14 still equals 10. So add a positive 14. Positive 14 plus 10 is a positive 24. So this becomes 0. 10 plus positive 14 is positive 24. And now 1/3 of z, of 3z, tells you what 1z is, and that's 1/3 of 24, which is equal to 8. 1/3 of 24, or 24 divided by that 3, equals 8. So now you know that z is equal to 8, and you replace z up here in the equation and check it. So I'm going to replace z with 8. And I'm just going to go through the calculations. 8 plus 4 is 12. And 5 plus a negative 8 is negative 3. So 5 minus 8. Most of you then will learn that you add the additive inverse to do this calculation. So now you have 8 negatives and 5 positives. That leaves you with 3 negatives. And it's 2/3 of that negative 3. Well, 2/3 of negative 3 is negative 2. So this becomes negative 2 down here. 2/3, think about that, 2/3 of negative 3. So you have 3 things, they're all negatives. 2 of those 3 things is negative 2. So 2/3 times, I'm showing here that you can look at this as the opposite of 2/3 of 3. So maybe it's easier for you to look at this as 2/3 of 3, that's 2, and then the opposite of that is negative 2. On this side, 1/3 of 12 is 4. 12 divided by 3, or 1/3 times 12, is 4. 4 plus a negative 6 is negative 2. So you're left with negative 2 equals negative 2, and that solution checks. For problem 3, Elena says that there is no solution to this equation. 9x plus 15 equals 3x plus 15. Because you're adding a value, you're adding 15 to different things. So there's no way that you could get 9 of these things equal to 3 of those same things. So she doesn't think there's any way that there's a solution to this equation. So do you agree? Explain your reasoning. So let's go through and solve it first. See if we can get a value for x, and that would show you, or that would prove that there is a solution. Well, you have 9x plus 15 equals 3x plus 15. Get rid of the 15s by adding a negative 15 to both of these. You end up with 9x equals 3x. Now, if you have 9 times some value times some number equals 3 times that same number, there's only one way that you can get those to be equal, and that is if x equals 0. Think of it the other way. Say that you know that x is 0. 0 times 9, 0 times some factor, is going to be equal to 0 times any other factor. So 0 times 9 is 0. That's going to be equal to 0 times 3 is equal to 0. So if you work through, so 9 times 0 is 0, 3 times 0 is 0. So there is a solution. X is equal to 0. But let's solve it a little bit more. So let's add a negative 3x to this side to get rid of that 3x. So now 9x plus negative 3x equals 0. Add these together, you end up with 6x equals 0. So 1/6 of x is the same as 1/6 of 0. 6 times 0, 6 times 0 is going to be equal to 0. You don't have anything, so whatever multiple of that nothing is still equal to nothing. So there is a solution. Multiply the same factor x by different factors, 9 and 3, get the same answer. The only way you can do that is have x equal to 0, so there is a solution. That solution is 0. So up here, 9 times 0 is 0, plus 15 equals 3 times 0 is 0, plus 15, 15 equals 15. This is problem number 4, and this is a review of lesson 3 from unit 3. And it says that you have a table of data for 2 quantities, x and y, and that is a proportional relationship. So once you see those words, proportional relationship, certain things should kick in your head of what that means. For example, you should think that it's a straight line. So on a graph, it will be a straight line, and x and y are related through multiplication, and that's called the constant of proportionality. It's a lot to think about, but once you have a picture of what's going on, you can begin to just see it. So y equals kx is the equation, and that constant of proportionality is the factor that relates, that forms that proportional relationship between the value of x and the value of y. It goes to the origin. If you have 0 of one quantity, then you have 0 of the other quantity. Also, there's a scale factor. Now, we haven't talked about this very much, but the scale factor in essence is just equivalent fractions of the constant proportionality. So 2 over 2 times y over x is going to give you an equal value, just renamed a different way, and that is a scale factor. And we haven't done that much, but a scale factor is involved in proportional relationships. So it says complete the table. There's an equation, y equals kx. Complete the graph. You know it goes through 0, 0, which is the origin. So a lot to think about. So just go through it systematically. Don't worry about it too much, just step by step. So the proportional relationship, here's the equation, and k is the constant of proportionality. That is y over x. So remember that for a proportional relationship, the y-coordinate is the length along the y-axis. The x-coordinate is the length along the x-axis because they're proportional relationships. So that means you can take y and divide it by x. So these just become equivalent fractions. They're all equal to the same value. They're just written in a different way. So 21 divided by 14. So 21/14 can factor out the 7, and you end up with the simplified fraction or the simplified ratio of 3/2. Now, do you see, so it's 3/2. So what's 1/2 of 14? That's 7. So that's 1/2. 2/2 is 14, and 3/2 is 21. So you go up here, what's 3/2 of 14? Well, 1/2 of 14 is 7. 2/2 of 14 is 21. 3/2 of 14, 2/2 of 14 is 14. 3/2 of 14 is 21. So you get to that 21, and notice that the y-coordinate is larger than the x-coordinate by 1/2. So look at the 64. Do you see that the y-coordinate is larger than 64 by 1/2 of 64? Half of 64 is 32. Add 32 to 64, you get 96. So it's 3/2. 1/2 is 32. 2/2 is 64. 3/2 is 96. Now, if they give you the y-coordinate, now you have to go the other way. You have to look at the multiplicative inverse of the constant of proportionality. So rather than 3/2, it's 2/3. So just picture this 39 as being divided into 3 equal parts. That's 13 per part. 2 of those parts is 26. Now you go back the other way. Half of 26 is 13. Add that 13 to the 26, and you get to 39. I don't know if this is too much to think about or not, but it's a visual way of picturing what's going on. So you can test yourself. So 3/2 of 26, does that equal 39? Well, 1/2 of 26 is 13. 2/2 of 26 is 26. And then add 13 more. So for 3/2 of 26, do you get to 39? And in fact, you do. And for the last one, 1 times 3/2 is 3/2. Well, 1/2 of 1 is 1/2. 2/2 is 1. 3/2 is 3/2. So the constant of proportionality is 3/2. The equation is y equals 3/2 x. Again, these are just equivalent ratios. 21/14, 96 over 64. 39 out of 26, or 39 for every 26, and 3/2 for every 1. So the y-coordinate is larger by 1/2 more than the x-coordinate. Okay, now to graph them. So look at the y-coordinates and pick out the largest one. This is going to help you decide what to make the scale. So the largest is 96. The largest of the x values is 64. So that means on your graph, you need to get out to 96. And on the x-axis, you need to get out to 64. So you have to decide, what am I going to label these? 10, 5, 10, 2, 100. What am I going to label these so I can get out to 96? So I usually just If you look at 10, there's 14 lines. Count the number of lines. 10 times 14 is going to get you to 140. The important point is that 96 is included, so 96 is about right there. And you can use 10 along this axis as well. 10 times 141, or 10 times 14, once again, will get you out to 140. So the 64 is going to be right here. Now the x-axis, you can actually make these 5, because 5 times 14 is 70. So that means the 64 is going to be within this axis. You have to think about that a little bit, but let's look at the graph as the axes are labeled right now. So you plot each of these points. 0, 0 is on the line because the line has to go through the origin. And so these are each of the coordinates from the table, and they do fall on this straight line. Now I said a moment ago that you could make each of these lines equal to 5 units. So this goes back all the way back to Unit 1 from 7th grade, where if you change the axis in scale drawings, or the scale for scale drawings, instead of making this 10, let's make the scale half as big, so 5 units instead of 10 units. So this is going to be 5, 10, 15, 20, 25, 30. So look what happens to the drawing. So if you make the scale half the size, then you have to go twice as far to reach that number of units. So you make the drawing, in this case, the graph goes along the x-axis twice as far. So notice that for the scale where it's 10 units per line, this is 14. Where it's 5 units per line, the point is twice as far along the x-axis because you have to go twice as far to reach that same number of units. So if you make the scale half as big, you're going to make your drawing, in this case, stretch the x-axis out twice as far. So this goes out to this point right here, twice as far as to this point right here. So the 26 is right here, the 26 is right here. Up here, 64 is right here, but twice as far, 64 is out here. A little bit much, but that's okay. You know, it's a good idea to look back and see how different things that we've done in the past fit into what we're doing right now.